Okay, so this is going to be a video on 13.3, just graphing from an equation. So I give you a form, and then you know which of these to start with, and then you use that information to help you make your parabola or your U-shape, however you're thinking about it. So step one is when you see this format, you should know which format it's in, and the reason for that is because then it'll tell you this or this pretty quickly or easily, right? So you should recognize vertex form when it has one set of parentheses, and that's it. The square is on the outside of that. That's how we know we're gonna make that U shape, is that square exponent. But then the parentheses tell us that we're in vertex form. So remember, the vertex you get by changing the sign of the parenthesis. So whatever number is hanging out with the x, in this case, -2, we're gonna do a sign change, and then we take the number in the back and we leave that number alone. So you're just pulling them in order, taking the opposite of the numbers in parentheses and then keeping the number in the back the same, and that's your vertex. So yay for one piece of information, and it's an important one because that vertex will give us the very beginning structure. And so if you remember, looking in front, it's a positive version, so I know that my U shape, my prediction is that it looks something like this. I'm not exactly sure where it crosses the x-axis. That's where the x-intercepts come in. So then let's solve for that so we can get an accurate representation. So the way that we solve for x-intercepts, the same way it's literally been in Unit 11 and in Unit 12. In an x-intercept, the y is always 0. So we're just going to take our equation and make it equal to 0. Oops, I forgot the equal 0 and the y. All right, we just make the y equal to 0. And if you don't like that equal 0 on the left, you can put it there because we need the output to be 0, so it's okay if it's on the outside as well. And now we're back to our traditional questions of how to do 13.1. So if I give you a problem that looks like this and you say, okay, I see an x in only one position, and so I'm thinking that this is an undo kind of problem. I'm going to take everything that I see and I'm going to undo it. Always in farthest away from the parentheses, farthest away from the x first. So what I mean by that is we get rid of this first, then this, and then that. They always go in this kind of order where you're closing in on that variable, on that, that x or whatever we're solving for, right? So the farthest thing away from x is that -9, so we undo that -9 by adding a 9. Then we're going to undo the square with a square root. The square root of a square is an absolute value. The square root of 9 is 3. And then to solve that equation, again, we're going to go left and we're going to go right. So when we go left, we're going to -3. When we go right, we go to +3. And then you solve the equation like you normally would, right? So just isolating that. To get x by itself, we just add 2. So x is 5. If I add 2 on this side, x is -1. Remember, those are x-intercepts, so they live here at -1 and here at 5. The parabola looks as it should, and we'll write our x-intercepts in x-intercept form. So short story for this is the vertex, like vertex form, gives us the vertex by changing this and leaving that number alone. And then you solve for the x-intercepts by setting the equation equal to 0, so the output is 0, and then you undo this by its opposite. So if it's addition, you do subtraction. If it's subtraction, you use addition. Then you undo a square with a square root, leaving you an absolute value, which splits into one positive version of this and one negative version. The x minus 2 in the bars, that stays exactly the same. We're just going left 3 and right 3, which is where we get those two numbers from. Okay, so let's take a look at something different. What if we have an equation that looks like this? So you're thinking, okay, I'm going to do either this or that, and I don't know what the vertex of that is because this is not vertex form. So you want to be really careful when you're looking at something that looks like a box problem. You are looking at something that is not vertex form. And if you are not in vertex form, then you shouldn't be doing the vertex, right? That's not going to be your first strategy. So then move on to x-intercepts and do the same thing we did before. X-intercepts you always find by making y equal to 0. So I'll go to the equation. I'll make y equal to 0. Again, if you don't like where that equals 0 is, feel free to move it to the output side. And then now we've got a box problem, so I'll do the box problem. First combo that comes to mind is 8 and 2, which gives me 10x on the diagonal. And what I have in the middle is a 4x, so I guess 8 and 2 wasn't right, so let me try something else. I think it's 4 and 4. So now we've got x plus 4 from the outsides and another x plus 4. And then if you remember when I said, when you've got the same dimensions on the side and here, when we've got two edges that match, we've got something that looks like a square. And so we're going to write it as x plus 4 squared because it literally is a square. And so then if you remember what I just said, if you are looking at an equation that has one set of parentheses, you are looking at vertex form. And you get the vertex from vertex form by taking the opposite of what's in the parenthesis and then looking at the number in the back. So our vertex is going to be negative 4, 0. So all of a sudden you're like, okay, not only is that negative 4 at vertex, it's also on the x-intercept, so those are going to be the same in this case. And that's okay. Sometimes you have that kind of stuff pop up. So now you're like, okay, great. I have a parabola that's facing up because, again, that x squared is positive, so it looks something like this. And a sketch would be good, but what's better than a sketch is more accuracy. So the way that we get more accuracy is through these points. We've got an x-intercept, which we figured out. We did the vertex. What I never asked you about, except what you'll need, is the y-intercept. So remember, you always find the y-intercept by making x 0. So if I go to the equation, x squared plus 4x plus 16, there was a y equals at the very front of that. If you remember, I'll go to that equation and I will make all the x's 0. And if I do that, then I'm going to get 0 squared, which obviously is nothing. 4 and 0 is nothing, and then a 16 at the end. So I input 0 as my x, I output 16 as my y value, and that's my y-intercept. So if I had space 11, 12, 13, 14, 15, 16, that's my dot up there. And then to make a perfect U shape, I can just use mirror image symmetry, meaning figure out how far over this is. It looks like this is 1, 2, 3, 4 blocks to get to this point. So over 4 and up 16. So if I go over 1, 2, 3, 4 and try to mirror image, I could get that mirror image dot on the other side. Again, if I had more accurate tick marks, that would be really helpful, but I don't, and that's okay. So again, if you've got these box problems, we're going to do the box and we find the x-intercepts first, and then we find the vertex by finding the middle of those x-intercepts. But in this case, the x-intercept is only 1 because these two parentheses match. So by turning into vertex form, you get the vertex and the x-intercept because that's the same in this case. And then you use the y-intercept to get this point, which you can reflect over here. Kind of like if you were folding the page over, this would match up with that. Okay, I hope that helps with your graphing and you're all ready for the test.